Hello everyone, my name is Sheida Shakeri. I'm a PhD student in landscape architecture at Istanbul Technical University. Today I will be presenting our research with my advisor Dr. Muhammed Ornek, which is titled How Metaverse Evolves the Architectural Design. First of all, what is Metaverse? The term metaverse, which combines the word meta, meaning beyond, and the word verse from the word universe, refers to the next generation internet in which users can interact with software applications and other users as avatars. However, metaverse is not a brand new idea. The term was first used in Neil Stephenson's science fiction book named Snow Crash in 1992. In this book, Stephenson defined the metaverse as a vast virtual environment that exists alongside the real world and in which people communicate via digital avatars. Later, in 2021, after rebranding Facebook to Meta, the metaverse concept gained widespread popularity. The metaverse, once thought of as a solitary virtual universe, is now changing into a multiverse in which virtual worlds overlay the actual one. There will be seamless integration between actual and virtual spaces, people, and activities. Therefore, physical and virtual worlds become more entwined. On the other hand, architects have always relied on visualization tools to develop their concepts for specific design problems. However, the final visualization emerged from the actual architectural functions, structure constraints, gravity, materiality, privacy, and physical laws, meaning that architecture evolves the digitally represented visualizations. However, with the growth of the metaverse, all physical restrictions are being eliminated. Metaverse offers endless possibilities for architectural design by combining virtual and physical entities, such as architectural features, human presences, and artifact properties, to host hybrid and dynamic activities. Hence, there is excellent potential in the architectural requirements of the metaverse, which can serve actual architectural practices. This study aims to identify the role and effectiveness of the metaverse in actual architectural design. Thus, the metaverse architecture will be examined based on its main features in three phases, and it will be compared to the actual architectural processes in each step. These phases include tools, design methodologies, and place characteristics. The tools are classified into the recent cutting-edge technologies that are used in metaverse and some virtual environments, including game engines, artificial intelligence, digital twin, and VR, AR, MR, and XR. Secondly, the design methodologies of virtual environments are analyzed. And finally, the place characteristics of the metaverse and architectural designs are compared. This roadmap will help us to detect the current bottlenecks in architectural design, which can be solved by retrieving knowledge from metaverse applications. First of all, 3D modeling for the metaverse integrates expert knowledge from various domains, such as user interface, content, character, and game design. To do so, game engines are used to create the spaces within the metaverse. Although numerous game engines are on the market, Unity and Unreal are the most remarkable ones today. On the other hand, in actual architectural design, architects use 3D modeling software like 3D Max, Blender, Cinema 4D, or Maya to create 3D models, which concentrate on construction details mainly. Fortunately, today, some university architecture studios have started using game engines as central design instruments in actual architectural designs. By this way, students got a much enhanced understanding of the spaces and took advantage of time-based design opportunities that were not available when working with other media. They highlighted four main advantages of real-time modeling with game engines over physical scale modeling, including comprehension of the scale, engagement of other senses with sound, understanding of space and time, and the ability to interact with others in a virtual space. However, real-world projects lack the extensive use of game engines, and very few practical methods can enable a professional designer to effectively interact and collaborate with end users on a functional level. As another cutting-edge technology, artificial intelligence or AI is a second tool to compare. While actual architecture benefited from this tool mainly in the fields of pattern recognition, early stage design, space planning, automatic generation of the new design, dynamic optimization, crowdsourced design, digital fabrication, and form-finding optimization, AI in the metaverse advances automation for designers. However, there has not been much progress in using AI to simplify user interaction and enhance the immersive experience. Next tool we are going to talk about is digital twin. The idea of a digital twin claims that every system comprises of a virtual and physical system, which are related to each other. It is believed that incorporating digital twin design principles into the metaverse can provide consumers with actual qualities, increasing the appeal and usability of the metaverse. We can create digital twins in the metaverse for structures, items, and settings that already exist in the real world. However, in actual architecture, digital twin is mainly used for construction approaches. Most of the projects applying digital twin technology to the construction phases focus on the structural system's integrity of the object. Finally, virtual reality or VR is a computer-generated environment that closely resembles reality to the person experiencing it. This tool is highly utilized in architectural visualization and it enables a better understanding of complex designs. It also supports collaborative decision-making. On the other hand, VR in the metaverse acts as a platform where multiple users receive identical information and interact in real time. Also, augmented reality or AR improve user interaction with digital entities by expanding users' visual areas. But in actual architecture, AR is used for construction maintenance and productivity and architectural and environmental planning. As another version of AR, mixed reality or MR mixes the virtual and physical worlds, and users can experience the metaverse through many other realities in physical and virtual realms. Besides, in real-world projects, MR is used in the AEC industry, prefabrication, site survey, and remote design problem solving. Last but not least, extended reality refers to real and virtual mixed settings and human-machine interactions, which unifies AR, VR, and MR. In the metaverse, users can control their avatars using XR and user interaction techniques. And in actual architecture, XR technologies simulate building projects in multidimensional digital models and aid all phases of a project in the AC industry. As the metaverse is still in its early phases of development, there is no consensus on how it should be structured. But some attempts have been carried out to deal with this problem. For instance, layered metaverse methodologies were established. It is a 7-layer metaverse design that includes infrastructure, human interface, decentralization, spatial computing, creator economics, discovery, and experience. This methodology is broken down into a 3-layer metaverse design. Infrastructure, which establishes the fundamental and physical necessities such as the blockchain, network, and processing power. Interaction, that links the infrastructure and ecosystem levels where the metaverse contents are formed. And ecosystem, that combines AI, economics, and user-generated content. Additionally, design methodologies of digital games as the most similar virtual environment to the metaverse can be adopted. Overlay method is proposed to design the virtual space within the digital games. In this method, after defining the game's concept and type of its place, player's activity is developed as bubble diagram. Then story, natural environment, artificial environment, and media with information are added. And finally, we file them all together and build a master diagram. As another choice, the algorithmic approaches of 3D modeling as a methodology for the effortless generation of adaptable visualizations can be adopted in metaverse design. When using algorithmic design, the architect creates the program that creates the digital model. So architects can model more complicated geometries, automate time-consuming, repetitive operations, and quickly generate a variety of design alternatives. The third and the last phase is analyzing of place characteristics in both the virtual and physical worlds. Researchers have found several spaces to form and flourish good places. As you see in the table, the physical place aspects in many research include form, activities, meaning, physical, psychological, and social features. On the other hand, virtual places are somehow identical to physical places because it has been built on the communication networks between humans, their environments, social traditions, and other personal experiences. According to several researchers, virtual places are based on setting, community, meaning, communication, and interaction. Also, according to Kim et al., virtual places are classified into 5 categories of story, space shape, action dimension, user complexity, and interaction level. These categories are all divided into subcategories and all are explained within our paper. By assessing the main characteristics of metaverse architecture and actual real-world architecture, we detected the similarities, differences, bottlenecks, and potentials of each. We highlighted the following results. First, while every single detail can be highlighted in the metaverse design, architectural projects concentrate on construction details and leave out minor details that are less important to the topic. Real-world projects lack the extensive use of game engines as a virtual platform to interact with others. AI has been used to its maximum potential in architecture, whereas there has not been much progress in using AI to simplify user interaction and enhance immersive experiences in the metaverse. While the digital twin in the metaverse mainly focuses on the design phase, architecture mainly utilizes this tool for construction, focusing on the structural systems. VR, AR, MR, and XR tools focus mainly on construction, prefabrication, and the AEC industry instead of architectural design, while metaverse benefits from these tools. Although containing different design methodologies, virtual places drew inspiration from architectural design methodologies in some cases. Both architectural and metaverse designs contain structure and layers, although they do not have the same functions. Meaning and the story remain the core concept in both virtual and physical spaces. For virtual places, interaction has a greater degree of importance, which is mainly ignored in physical spaces. Along our journey to define the fundamental ideas of the metaverse that could affect architectural design, we extracted the challenges and opportunities of both actual and metaverse architecture. Accordingly, both of these fields can help each other to boost their place qualities. Yet further research is needed to achieve this ultimate goal. And finally, these are the references that are used in our paper. And we would like to thank you for your time and attention. And we would like to say that we are really grateful for the chance to present our work today. Thank you.